Hello and welcome to this live webinar on how to prevent physical contamination in food production in partnership with International Food Safety and Quality Network, BRCGS and Metal Toledo. I'm Simon Timpley, CEO of IFSQN, and I'll be your host today. Together, we'll explore why contamination detection solutions are vital for supporting product safety, quality and compliance with food industry standards. Presenting today, we have experts Adam Green from Metal Toledo and Merce Sanchez from BRCGS, who will share their insights on metal detection, X-ray inspection, and how these technologies help protect your brand and prevent costly recalls. Please note, there will be an opportunity for a Q&A session at the end of the webinar, so please do submit your questions throughout as they come to mind, and we will get to them at the end. So now I will hand you over to Adam Green to get the webinar started.
Thank you very much, Simon, and welcome to this webinar in regards to supporting compliance and consumer safety. So as we begin, why is there a requirement for food manufacturers to invest in inspection equipment? Well, if we look at the first reason, there is a key requirement for manufacturers to protect against damage to their brand reputation. There is also the requirement for manufacturers to reduce the risk of contaminated products reaching supermarket shelves and consumer tables. There is also a need for the same manufacturers to avoid the loss of contracts or potentially failing audits. And it's in their interest in order to protect upstream and downstream equipment in the manufacturing process. So before we dive into what type of inspection equipment can be suitable, there's lots of things that we need to consider before, as a manufacturer, potentially implementing technology into the manufacturing environment. First of all, we need to understand what are the potential risks. And this is going to be linked to a HACCP program that every manufacturer, especially in the food industry, will undertake for their production line. We need to look at the different potential insertion points for technology and where there are benefits in terms of the varying statuses. Of course, there is going to be a level of global compliance which we need to consider. And this is where we're delighted to welcome our partners from the BRCGS to talk more on this subject. The manufacturer also needs to understand the product packaging. Is this going to impact the type of foreign body inspection solution that I can bring into my manufacturing environment? There's also a level to understand what can each of those inspection devices do in terms of foreign body detection. Is there varying levels of performance within the categories in which they're able to perform? And then finally, of course, there are investment considerations that need to be undertaken before bringing equipment into the manufacturing environment. So let's start with the potential risks. So here is a select group of foreign material which can find its way into the manufacturing environment. If we start with metal, metal can get into products through a wide range of processing equipment. And if this is the key risk that has been identified as part of a program, this is potentially where a metal detector could be implemented within the manufacturing environment because it's looking for this particular type of contaminant. If we have an agricultural process, there are other types of foreign body that can find their way into food. For example, stones from a field or bones from the animal itself. In this event, if these are the materials that are at risk to our consumers or fundamentally foreign material that we don't want inside our product, this is where X-ray inspection could actually be the right solution for manufacturers to consider bringing into their site. But where is going to be the critical place to put equipment to avoid potential risks and challenges? Well, the manufacturing process is made up into a wide variety of areas. We generally categorize them into three key areas: front-end inspection, in-process, and end-of-line. But of course, as part of that HACCP program I mentioned earlier, all manufacturers are going to be looking to keep contamination risks as low as reasonably achievable. Of course, a series of good practices within the manufacturing process can enable this, and all manufacturers are fundamentally looking to be able to eliminate all contamination risks, and they can do this by one of two ways. They can try and prevent, and this can be done with items such as sieves to try and block certain size materials from going through. But in the event that you aren't able to eliminate by prevention, then we need to look at different pieces of technology which can detect. And this is where, by breaking down each of those three areas, front end, in process of end of line, we can look at bringing equipment, each having its own advantage. So if we think about the goods in part of the manufacturing process where raw material is coming in, you can remove potential risks at this early stage. This has two benefits. You can potentially protect upstream equipment, and this can be vitally important in manufacturing processes where there are cutting blades, especially if you're bringing in agricultural goods where stones are going to be a key risk, because obviously the relationship between stones and cutting knives can end in equipment being damaged and also breakages, which is going to cause you further problems. Of course, it's going to reduce the overall cost to a manufacturer, rejecting product at this stage because it has the least amount of value. It's not been thoroughly processed. If we look at in process, this could be after a cooking process, a mixing process, and generally involves product going into its primary packaging. Again, at this point, if you are to inspect and reject, there is a benefit that that particular product could potentially be reworked as it's not the final good. And then finally, we have our end of line inspection. And this is in the majority of cases where most manufacturers put their critical control point, because essentially it is the final stage in which a product, a final good, can be inspected before it goes out to retailer shelves. And this is where that element of brand protection can take place. And in terms of the types of metal detectors and X-rays that can be implemented, there's a wide range of solutions. And here you can see, depending on where potentially you might want to place the inspection solution, there are conveyorized options, there are gravity foil options, and there are pipeline options, to name but a few. In the same way, from an X-ray perspective, depending on where you necessarily want to put the inspection solution is going to change the type of conveyorized solution. So for example, we have bulk flow solutions for incoming goods. We have package solutions and tool rigid containers for either in process or end of line. And then in a similar way to a metal detector, where there is not a requirement for a conveyorized solution, this is where you can look at pumped products, all with that target of inspecting and rejecting potential contamination risks to the end consumer. Now, of course, we need to understand the risks, we need to understand where we can place the technology, but there's also going to be a level of global governance which is helping manufacturers and guide them to the right type of solution. And this is where we're going to be delighted to welcome Mercy as part of this presentation at the end of my slides, in order to talk more when it comes to global compliance and how this can help food manufacturers take the next step into providing healthy and safe product. Now, there's also going to be a requirement for food manufacturers to understand the product that they're making and how that's going to impact the type of inspection technology that they are going to be able to have in their manufacturing process. And the reason for this is, first of all, we touched on it at the beginning, there are two main types of foreign inspection solution, metal detection and X-ray. And between the two different types of technology, there is a difference into the type of foreign bodies that they can identify. I'll reiterate it again, metal detection is primarily focused around the detection of metals. But even within the category of metals, there are subcategories such as ferrous, non-ferrous, and stainless steel. With an X-ray, it can detect a wide range of foreign bodies. We mentioned a few earlier, stone, bone, rubber, but there are other types as well. And we're going to go in a little bit more detail on what exactly an X-ray can or cannot detect slightly later on. The product type. And this is when it comes to where the machine goes into the site. This is where, for example, there's a lot of similarities between the types of solution available. We saw from the portfolios, both types of system have conveyorized solutions, both have bulk flow and loose flow types. But in the example where you want to implement a inspection device in and around a multi-head weigher, an X-ray does not have a gravity force system. And in this type of application, a metal detector is going to be your only option. But I mentioned at the beginning packaging types and why that's important. Well, this is based on the way in which each type of inspection solution is working. So metal detectors are all about conductivity. And this will therefore impact or be impacted by the type of product packaging that you potentially want to pass through a metal detector. So for example, a metal detector is quite comfortable inspecting cardboard or plastic packaging. However, when there is potentially metal cans or metallized film packaging, this is a type of packaging material which is going to add its own level of conductivity to the product and therefore impact the performance of a metal detector. In a similar way, if you had a glass jar but with a metal lid, again, this would not be something you'd be able to utilize as an inspection device in that application because the metal will essentially wreak havoc with the metal detector. In contrast, X-ray inspection, because it's all about a principle of density, as long as the foreign body, and we'll cover this slightly later on, is denser than the packaging type, it can be detectable. And this is where X-ray inspection can effectively, successfully inspect a wide range of packaging formats, such as cans, glass jars, ceramic, plastic, and cardboard. So depending on the type of packaging you use for your product, it's going to lead you on a direction as to the right type of inspection solution for you. And this is a really important point to consider. Now, I touched on it briefly in terms of the two different ways in which the inspection devices work when it comes to conductivity and, of course, density. Now, I mentioned one particular way, which was about the packaging in which sensitivity can be impacted. But of course, there are multiple ways in which manufacturers need to consider when they're bringing inspection equipment on, there are going to be things that can impact the performance. I mentioned earlier on, there are subgroups of metal when it comes to metal detection performance. You have ferrous, non-ferrous, and stainless steel. And depending on whether that material is either conductive or magnetic, there is going to be different results across those three subcategories between ferrous, non-ferrous, and stainless steel. So again, depending on the risk, there needs to be an understanding that there's not necessarily going to be one type of metal detection that's going to be the same across the board. There's also needs to be a consideration to aperture size and product positioning. So when it comes to a metal detector, the weakest point of inspection is in the middle of the aperture. Also, the larger the aperture size, the weaker potentially the performance. And this is important if you have a wide range of product sizes, because of course you need to ensure that you have a metal detector head suitable for all product sizes. But in the event that you have a small, medium, and large, there needs to be that consideration that the size of the aperture is essentially going to impact the performance on the smaller product to be able to cope with that larger size. So again, it's something to consider. Environmental conditions and product characteristics are also going to be vitally important. There needs to be a metal-free zone in and around the unit in order for it to perform at its best level. And product characteristics as well, so whether something is considered wet or whether it is considered dry, is going to have an impact on the metal detector. Not only that, temperature as well is also going to have an impact. Something that was frozen that starts to thaw is going to give off a different product signal when it's thawing in comparison to when it's frozen. So again, depending on where you put the metal detector in your line, especially in an application like that, is important as to the type of performance that you're going to get. In a similar vein, there are also elements that are going to impact performance of an X-ray machine. I mentioned earlier it can detect a wide range of foreign bodies, but it can't detect all foreign bodies at the same level. Each material has a different level of density. And this is going to impact the type of foreign body and the size in which you can find it with an X-ray. Now, while with a metal detector, the position of the foreign body is important in relation to where it sits in the aperture, with the weakest being in the middle. In contrast, an X-ray, where it's looking for the foreign bodies, it's not necessarily the middle of the beam that's the weakest. Rather, it's the location of the foreign body in relationship to the overall product which will impact its performance. So if we take the example of a metal can, if a foreign body is situated next to that wall of the can, the density of that metal can is going to add to the overall density score, which will then impact the performance, versus if that foreign body was sat in the middle of the product away from that thicker edge of the can. So the location of the contaminant is going to play an important role as to whether you can find that foreign body or not. And particularly in certain types of packaging, you will get different levels of performance in the top, the middle, and the base. Product height, but also product width, and this is very much linked to the overall density. So the key dimension will always be the thickness of a product in the direction of the X-ray beam. So product height would be important with the generator situated above the conveyor, because that is the thickness that's going to add to the level of density. In the reverse, if the generator was in front of the conveyor, it would be the product width. So these are the product characteristics that add importance when it comes to sensitivity in comparison to a metal detector, which is very much about wet or dry or temperature concerns. Product presentation is also important to an X-ray. Delivering a product in a repeatable manner is the best way to get the performance out of the X-ray, but also to ensure limited false rejects. And you can also see how I've put product characteristics, but it's different to metal detection in terms of the type of characteristics. I mentioned with metal detectors about wet or dry, hot or cold, for example, but to an X-ray, product characteristics is more about, is there overlap within the product? Is there areas of air? Are there things that are going to impact the noise of the image, like pasta sitting on top of each other? Anything that's non-monolayer. These are the types of product characteristics that fundamentally impact performance on an X-ray. So there are some similarities between the inspection devices, but there are also some clear differences to consider. Now, I mentioned specifically with X-ray, it was all about density and that different materials have different types of density. Well, here you can clearly see a table which lays out varying types of material and their specific gravity, which equates to the density value. So for example, you can see highlighted in blue, we have our reference point of water at 1 centimeter cubed. This is generally considered a typical food density. What this then provides us is a general rule of thumb when it comes to X-ray inspection. If a foreign body floats on water, it has a lower density than water, it cannot be detected by X-ray technology. And this is why you can see some foreign material situated within the table above water. You can see that we have wood, insects, fruit stones, and low density plastic. These are undetectable to X-ray technology. However, underneath our blue line, you can see that we have a wide range of foreign bodies of varying levels of density. You will notice, in comparison from the typical density element to the table and the detectability, there is a direct correlation to the greater the density level, the smallest or the smaller sizes that you are ultimately able to find that foreign body in. And this is why to X-ray, metals will perform best in terms of it can find them in the smallest sizes because they're typically the densest material. You'll also see between the groups of ferrous, non-ferrous, and stainless steel, there's very little difference from a density value. And this means to an X-ray, it's pretty much the same result between ferrous, non-ferrous, and stainless steel across the board, with the exception of aluminium. You can see aluminium has a significantly lower density of 2.7. And this is why, generally speaking, with X-ray inspection, you'll generally find that the groups of ferrous, non-ferrous, and stainless steel is grouped under one category for stainless steel because of those similar densities, but there is a different test sample or category for aluminium because of that density difference. You'll also notice highlighted we've got two different comments on glass. And you'll see that because of that, there are two different levels of density. And this is just something to consider, that from a test piece perspective, there are 5 different types of glass test piece in the marketplace, all in varying levels of density. So if glass is a key consideration for you, it's important to do your research in advance to understand what type of glass your packaging is made out of, to understand what the reliable detection performance is going to be from an X-ray inspection perspective. Now, the majority of what we've spoken about so far is all about product safety. And of course, that is a primary concern for manufacturers. But one of the added values that X-ray can provide is we capture an image. And therefore, when we have that image, we are able to do additional checks to protect that level of brand. And we can do this by a series of what we would define as quality or integrity checks. Here you can see an example of a completeness check, looking to count the relevant number of products inside the carton. We can look to perform a radiographic mass check. So it's a fill level check, but it's different to a weighing scale. But fundamentally, it will offer a service in able to provide an understanding of whether a product is overfilled or underfilled. Again, depending on the shape and size of the products inside, we can look at individual product fill levels. So it's a combination of the completeness check and the overall fill level. So with each of those individual chocolates inside the box, not only are you counting to make sure that they're there, but you're also then providing a fill level check on each of the individual products inside. And this is where, for example, it can have a value over previous inspection devices for weighing, because if you have one over and one under, that can level out to the same value. Whereas with an X-ray, doing those individual fill level checks, with one being over and one being under, that pack could be rejected. And then finally, obviously from a product longevity perspective, there are checks that can be performed as to whether product is trapped in the seal. Of course, this is going to compromise the seal and potentially lead to a reduction in shelf life, which of course is undesirable from a retailer's perspective, because they obviously have less opportunity to sell that product on, and there is potential health risk thereafter. There are other types of check that can be done. We can look at for the presence of clips, for example, and whether certain other things are in place, such as closures or caps. So this is just something to consider with when looking at X-ray inspection. What else can it provide other than that primary purpose of foreign body inspection? Now, how can a manufacturer understand whether it's right to go for a metal detector or an X-ray in their manufacturing environment? Well, we've listed a number of reasons why that might be. It could be the nature of the product itself. It could be the nature of the packaging. It could be global governance that's directing you. But one of the best ways in order for manufacturers to evaluate which is going to fundamentally provide them with the best level of brand protection is to test before you invest. Now, one things that we can do, especially from Metler Toledo, is offer a free of charge testing service out of one of our regional centres. This will allow you to send your product to said test centre and necessarily be able to compare the difference in performance between a metal detector or an X-ray. And that can give you the understanding and the confidence to communicate to your onward customers as to a level of product safety you're able to achieve, but also give you that level of understanding of what risks from your manufacturing process that you might have identified can be prevented from reaching end consumers. Now, finally, before we move on and bring Mercy into the presentation, of course, there are investment considerations as well. So not only is the equipment performing slightly different functionality, it also has slightly different elements to consider. So for example, one of those would be temperatures. So again, metal detectors and X-rays are able to operate in different environments, and this is something to consider. X-rays generally are a little bit more restricted, especially from a temperature where it can be situated, because it needs to have a certain condition for the electronics inside. We've mentioned product effect. Again, that's something that needs to be considered with regards to whether it be the characteristics of the product, whether it be the packaging, all of these are going to impact whether that investment should be looking at one piece of technology or another. The contaminant size. So again, metal detection, the detection capabilities are limited to the material's conductivity and how different that is to a product. To an X-ray, it's limited to the size of the diode inside the detector. And again, this is where, depending on what type of risk you're looking to understand and detect, it's important to consider the difference in performance for these two different inspection technologies. And finally, there's also a safety compliance topic as well. Metal detectors have less requirements from a health and safety perspective. With an X-ray, because essentially it is producing radiation, there are a series of things that need to be considered. There needs to be a notification out to whether it be a national or international body that you're bringing an X-ray onto site. There needs to be a level of training conducted on site in order to have the necessary knowledge on site to perform the necessary periodic radiation checks that have to occur with an X-ray machine. So again, depending on all the other considerations, there are other elements that also need to be considered before bringing the technology onto site. So I understand that's a very flying visit through all the various different considerations for manufacturers when it comes to trying to understand the right technology to keep their brand safe. Fundamentally, each manufacturer will need to undergo their own risk analysis, and within that, they need to understand the key requirements from the compliance, which Mercy's going to talk about, but also what risks could potentially come in. Now, again, there is an argument to say where potentially there is a need for both an X-ray and a metal detector within the same line, because there are different insertion points where, again, depending on that risk, we can look to have various different pieces of technology within that manufacturing process, fundamentally keeping products safe. But of course, at this point, I'd like to hand over to Mercy, who's going to take us in more detail through the world of compliance. Over to you, Mercy.
Thank you so much, Adam. Thank you for your presentation. Well, welcome. Only a few slides about who is BRCGS. Well, the most important is taking consideration that our vision is that science for safe world. Our mission is to improve the brand, conferring confidence to the rigorous supply chain assurance. And with the heritage of the British retail, we have evolved over 25 years into the range of the global standard. We have more than 35K certificated sites, more than 130 countries, and a large experience. Next slide, please. When we talk about the foreign bodies contaminants, it's important to take in consideration that we need to arrange the contaminants from two different points of view. In the standard, we address the foreign bodies against the chapter, the clause 4.9, chemicals and physical product contamination control. And we're talking about chemical control, metal control, glass, brittle plastics, ceramic, and similar materials, products packed into glass or other brittle materials, good, and other physical contaminants. In this section 4.9, the site shall address against different procedures and controls the risk of those foreign bodies that can be on the product, on the site, and can be an hazard for a risk for the product. Then the sites must implement adequate measures to avoid this contamination. And then we have 4.10, where we talk about foreign body detection and removal equipments. And that is important to take in consideration that we have 6 elements to detect and removal equipments that shall be considered under the standard. And, excuse me, for the sites. The first is that the risk of the product contamination, that this is the standard statement of intent, is the risk of product contamination shall be reduced or eliminated by the effective use of equipment to remove or detect foreign bodies. Then it's mandatory for the sites to have equipment to detect and remove. Mandatory, well, we will see that in 4.10.1, there is established that the selection and operation of the foreign body detection and removal equipment. Then the site shall cross risk assessment, identify which is the best equipment that they must provide on the different areas or production areas for detect and remove equipments. And then we have several elements. We have filters and sieves, metal detectors and X-rays, magnets, optical sorting equipments, container cleanliness, about glass jars, cans, and other rigid containers, and other foreign body detection and removal equipment. Next slide, please. Adam? Thank you so much. Great. Then when we talk from the beginning and in the 4.10.1, the metal detector and X-ray for the selection and operation of foreign bodies detection and removal equipment, there is necessary that the site must document, and it's established that a documented assessment in association with the food safety plan shall be carried out on each production process to identify the potential use of equipment to detect or remove foreign body contaminations. And typically, this equipment, the typical equipment to be considered might include, and we talk again about filters, metal detection, magnets, optical, other physical contact, and other physical separation equipments. Then it's important to understand this point and how the sites must have this documented assessment associated with the food safety plan. When we go to the metal detectors and X-ray equipments in the 4.10.3, the first requirement is that the metal detection equipment shall be in place unless the risk assessment demonstrates that the risk does not improve food safety. Then we need to have the metal detector equipment or the X-ray unless the risk assessment demonstrates that it does not improve the food safety. Where there is not used the metal detector, there is necessary a documented justification. The absence of metal detections will only normally be based only on the use of an alternative system, more effective method of protection. For example, X-rays, fine sieves, filtration, or whatever. Under the different clauses related with metal detector and X-ray equipments, we can see that there are requirements related with the rejection device, belt stop system, inline detectors, the procedure for the operation and testing of metal detector and X-ray equipments, the metal detector testing procedures, and the X-ray testing procedures. Then, for sure, each site must incorporate 4 or 5 of the requirements based on this section when there is a metal detector or an X-ray equipment. Next slide, please. In order to help to the sites to implement or to determine the best approach, in conjunction with Mettler Toledo, we launched a guideline against foreign body detection that was launched just 1 week ago, available on the Participate and under the BRCGS store. And here you can see a decision tree that was created by Medler Toledo, that there is on the guideline, that helps to the sites to identify which is the best approach, or which could be a good approach against the equipments to be used for foreign body detection and removal equipments. According with the nature of the product and according with the nature of the packaging, there is this decision tree that helps to the sites to have an approach about which is the best equipment. Next slide, please. But the most important thing is that we need to consider also is that foreign bodies detection equipments are usually considered as a critical control point. And as a critical control point, applies also the clauses under the hazard plan, the food safety hazard plan. And then we need to consider the elements against the validation of the critical limits for each CCP, and also the monitoring system for each CCP. Normally, when the sites identifies the need to have a foreign body detection and removal equipment, not the size of the patterns that are used should be against the nature of the process, the nature of the product, and also taking in consideration the sensibility of the equipment, for sure. But when these equipments are under a critical control point, that it's a key step, taking in consideration the process that is the last barrier, the last step to eliminate the hazard, the sites need to validate the critical limits. And this must be done by the hazard food safety team and must be documented. Then also we need to consider the monitoring procedure. And here we need to take in consideration that the different elements that requires. And normally there are non-conformities related with the foreign bodies detection and removal equipments when they are considered CCPs, because the monitoring system is not adequate or is not well recorded also. Next slide, please. Thank you so much. When we talk about the non-conformities only from the point of view of the section, the clause 4.10, we can see that the top 5 non-conformities are related with the metal detector erase and also against filter and sieves and magnets. But as you can see, the top 3 are related with 4.10.3. And we are talking about the metal detector testing procedures, about the metal detector or erase equipment, and the procedures for the operation and testing of the metal detection and erase equipment. We can move to the next slide. Thank you so much. When we talk about the metal detector testing procedures, the standard requires that this procedure shall include at minimum, that means that all of the next points shall be included, 5 elements. The use of the test pieces incorporating a sphere of metal of a known diameter to select selected based on the risk. The test carried out using separate test pieces containing ferrous, stainless, and non-ferrous metal. A test to prove that both the detection and rejection works effectively. The test of the metal detector by passing successive tests through the successive test packs through the unit at typical line operation speed. And the last one checks the failure system. Additionally, when there is conveyor belts, there are specific requirements. And also when there is inline metal detectors, then the test piece shall be placed in the product flow where it is plausible. Then there are specific situations that they are clearly established. This is the top one nonconformity when we talk about foreign body detection and removal equipments. And the nonconformities are related with the lack of control or fail on the rejection mechanism against the location of the test piece or the size of the test pieces, the test conducted out of the typical line operation speed, or also the control not conducted at the least sensitive area of the metal detector. Then it's a pity because it's clearly established all the requirements, but still nowadays we face that sites has challenges incorporating the requirements that are stated on this section. Next slide, please. The top two, it's about the metal detector or X-ray equipment that what shall incorporate. And again, there are three elements that must be incorporated. The first is an automatic rejection device for continuous inline systems, or a belt, and also a belt stop system with an alarm where the product cannot be automatically rejected, and inline detectors which identify the location of the contaminated to allow effective segregation of the affected products. There are three elements clearly stated according with the nature of the equipment. But what we can see in this case that normally there are issues with the belt stop system. There is a malfunction on the belt stop system, or there is an ineffective segregation of the affected products, or there are insecure containers. That means that the product could be also incorporated on the conveyor belt on the product, and it's a hazard to take in consideration. Next slide, please. And the last one of the top three nonconformities, all of them related with metal detectors and X-ray, is that the site shall establish and implement process for operating the testing of the metal detector or X-ray equipments. And in this case, again, at minimum, there must be four elements to be considered: the responsibilities of the testing, the operating effectiveness and sensitivity of the equipment, taking in consideration the variation against the particular products, the method and frequency of the checking the detector and recording of the results of the checks. Then there are again different issues that identify it, but the most important is that the procedure is incomplete according with what it's established on the clause. There is lack of records, and then also there are some issues about incomplete records where there is not clear the information that is stated on the requirement. It's important to take always in consideration that when the requirement request the clause, it's request several elements. Please guarantee that those elements are correctly understood and also implemented on site, because sometimes there is a delay or there is a lack of communication or understanding, and the implementation of the controls not always are easy. As you can see, the color of all top three nonconformities are yellow, that it's the part against the site audit, the part of the audit that it's on production site. It's the part of the implementation. It's not an issue about the procedure about the creation of the document, about the establish what must be done. It's all of the three elements, all of the three clauses on the top three non-conformities are related with the applicability on site about what is established on the document. Then please, this is quite so important. And also, if I can say, it's also related with the food safety and quality culture to understand for all the employees, in this case, production, the need to follow what is established against the procedures. Thank you so much. Adam, if you want to move. Thank you.
Thank you very much, Mercy. Really appreciate that. So we're bringing the end of this webinar to an end in terms of the content. If you do want to know more, we do have some options for you in terms of finding out more information. We have a section on metal detection, X-ray or both. We have more information on some of those integrity checks that are available. So again, if you would like to find out how X-ray and metal detection inspection devices from Mettler Toledo can help advance your brand protection, but also the ability for you to meet the requirements of the global legislation, then please do not forget to reach out to your local Mettler Toledo representative, or alternatively, if you do not know who that is, please feel free to go through our website and send us a contact form, and we'll make sure it gets directed to that relevant country, that relevant region, and they will make sure they're in contact. So at this point, we really appreciate you giving us your time. We'd like to open the floor up to any questions that may have come in. And if you haven't already, we do now have the chance for you to put questions in the chat, whether that be to myself, whether that be to Mercy, in regards to any of the content that you've heard so far. The floor is very much yours, and we look forward to answering any questions that you might have come up with.
Okay, thanks very much, Adam and Mercy. Very practical presentation. Excellent. And we've got 145, 147 people online at one time. So yeah, if you have a question related to the presentation, please put it in the Q&A. There are a couple there, so I'll pick those up now. Question from Trying. If I get your name wrong, I apologize in advance. Will you go through a calibration report in order to understand the different types of checks you do when calibrating an X-ray or metal detector? Can you provide any advice, on that?
Yeah, absolutely. Not necessarily in this format or this session in terms of a demonstration of how you can go through what we define as a PV or a PVR, performance verification. However, what we can do is we've got some information that we can share. Alternatively, we also have the ability to live stream the equipment that we have, both X-ray and metal detector, and we can show you how that functionality works. So generally speaking, from a calibration or perspective, from a metal detector, if we start with, there is a general requirement to perform, whether it's called a PVR, performance verification, or a PMR, performance monitor routine. Essentially, you basically need to test the metal detector periodically. Now, most recommendations are around every hour because there is some level of drift inside the detector during this process. And essentially what you would then do is you take your test piece and you would pass this through the metal detector at it, or during the middle, or I should say through the middle of the metal detector at the weakest point, to make sure that you can obviously detect the relevant sizes. And you do this with your ferrous, non-ferrous and stainless steel test piece. With an X-ray, you don't necessarily have the same level of drift. However, it is good practice to maintain this level of frequency in your testing. So again, you run on the X-ray what's called a PVR, performance verification routine, and it's exactly the same process, except this time you don't necessarily need to ensure that the test piece is in the middle. It just needs to be in or on your pack, pass through the beam. And of course, as long as it is detected, then you will have your pass with regards to your regular calibration checks. So hopefully that gives you a bit of context. as I said, with a metal detector, there's generally considered a requirement to test on an hourly basis. With an X-ray, it's not necessarily the same in regards to what you classify as the drift on the detector. However, it's good practice because obviously the longer that you leave in between either calibration or performance verifications, the more potential product you have to quarantine in the event that essentially that test fails. Hopefully that answers that question.
Great, thanks very much, Adam. Next question from PK Shakipur. Kindly confirm can X-ray detect the ceramic contamination, and what is the minimum size it can detect?
So to answer your question, yes, ceramic will sink in water and therefore it is X-ray detectable. Now, the size in which it can be detected is going to vary on a number of matters, such as the height of the product or the width of the product, depending on the beam geometry of the tank, whether it's at the top of the machine or the front of the machine. It will also depend on whether you're looking for, example, ceramic in ceramic, because obviously then we have to learn in as part of the teaching process to the X-ray your packaging. So again, the size of the ceramic could be different when it's in the middle of the product, for example, or whether it's next to the ceramic wall of the packaging. So to answer your question, the best way to find out the smallest size is to take advantage of our free test before you invest service, where again we have 3 regional test centers, one in Europe in Barcelona, one in North America in Tampa and Florida, and one in Asia in Malaysia. And you can send your product and we can pass that product through the X-ray with the full range of the potential risks, including ceramic. And from that, we'll be able to give you a test report which states what sample size could be regularly found. Now, it's also important to note that for both X-ray and metal detection, there is also orientation effect to consider. So again, depending on how that particular foreign body has found its way in, whether it's a shard, for example, whether it's a broken piece, there is going to be a performance difference depending on how that foreign body sits inside the pack. So for example, on an X-ray, if the generator's at the top, the weakest would be if you had a very thin shard lying completely horizontally, because it will have its lowest level of density. If it's standing up vertically, then it's going to have its greatest. So orientation effect is important. And that's why generally when we're performing tests, we use test spheres, because obviously that nullifies that and provides a reliable and repeatable result. But obviously things don't necessarily break in nice round balls in the manufacturing environment. So orientation effect is definitely something to consider. But to answer your question, the exact size of smallest piece is very much product specific. So apologies for not giving you an exact answer, but it is something that we would need to investigate.
Yeah. PK Shikapura has asked a sub-question. Can you please share test sample details of ceramic? Is it best to contact you directly to continue the detailed conversation on this?
Yeah, absolutely. We can take that offline and we can share. So again, it'll depend on where the ceramic is and obviously what that specific gravity is with regards to that material. But yeah, we can share that information offline.
Yeah, and the contact details will be in the slide deck. So
obviously, yeah, we will supply contact information with this webinar.
Okay, great, thanks. Another question from PK. What factor can you consider to avoid a metal detector and guide documents available to follow? I'm not sure I fully understand that. Do you fully understand that, Adam?
Well, the way I interpret it, a lot of that information was in Mercy's presentation as the different types of equipment that can be utilized in order to prevent. So, for example, there were things like sieves and magnets alongside other pieces of equipment like X-ray and metal detection. So it's going to be a challenge because obviously processing equipment can break and wear and tear. So of course there's going to be risks of metal getting inside your product. But as long as you understand the risks based on your risk assessment, where those potential risks are, if something breaks, what's the chance it can fall into my unsealed product, for example, and then implement the relevant piece of equipment to necessarily try and limit that, that's the best way that you can fundamentally try and prevent metal from getting inside your product.
Super. Okay, Albert, question from Albert. Is it necessary to calibrate metal detector? What's the frequency and what parameters are checked during calibration of metal detector?
So we sort of mentioned the time period earlier on, that sort of theoretical 1 hour mark. In terms of the parameters, again, that's sort of something we could probably show you in more detail in an offline or online one-on-one demonstration, whether that be via our online portal or whether that be in person, to really go into the details. But fundamentally, it's there to test the performance of your metal detector with regards to your foreign body samples. But again, that's something else that we can provide more detail on in necessarily a environment where we've got the metal detector to hand and can go through that in more detail with you to really make sure we answer all the levels of that question.
Sounds good. And another question from PK. How can Metal at Toledo support during fault troubleshooting, as you've just mentioned, I think?
Well, it's a really good question. So there's lots of different ways. So obviously we have, as part of our wide service network, we have multiple different ways in which we can support. So first of all, we offer a commissioning service. So should anyone choose to partner with Metal at Toledo, our service technicians will obviously come to site and commission the equipment, essentially set it up, get it ready for running in live production. But of course, support does not stop there. In terms of troubleshooting, we have a hotline that is available. We call it the Follow the Sun program, that our customers can ring to get phone support. Again, depending on where you are in the world, your time zone and your IT infrastructure, there is a potential for remote dial-in support, although obviously that has certain level of restrictions. And of course, we have the largest service network for on-site visits as well. So there's lots of different ways in which we can support our customers in terms of making sure once the equipment's not only installed, but it's also operating at its most valuable and optimal level during the overall life cycle of the equipment.
Thanks, Adam. Question from Huber. Is there any device to detect equipment oil leakage, e.g. electrical motor grease or oil bearing leakage?
I mean, it's a really good question. With regards to our specific technologies, obviously, where it's well known that oil will necessarily float in water, and therefore, from an X-ray perspective, it's not necessarily something that can be detected. I know we've got one of my colleagues on from Manchester. I don't know whether there's any element from a metal detector, whether that would be able to have an impact depending on whether it's got any conductive elements to it.
Hi, Adam. Yeah, it's unlikely that we'll be able to detect oil and grease with the metal detector. It might change the product parameters, but we can't guarantee that we'll change it enough to be able to make it inspected. So I don't think so, but without any sort of further product testing, we couldn't say 100% either way.
Okay.
Thank you, Dave.
Great, thanks. Question from Pete. How many times for the detection to be repeated after a positive signal of the metal detection in a separate product in a line? This is a question after several remarks after a GFSI audit, 1, 2, or 3 extra tests. Was there a standard?
Is that in refer to consecutive rejects? Sorry.
I'll just repeat the question. How many times has a detection to be repeated after a positive signal of metal in a product line? And they've had various different remarks in audits, 1, 2, or 3 extra tests. So is there some sort of standard on that?
In the standard, there is not established how many times shall be repeated the test after a positive signal. And I think that it's a conjunction, it's a response that can be also addressed, shall be addressed by Adam, but from BRCGS, the site shall establish the procedure when there is a positive signal to shall establish under the procedures, which is the practice to warranty that once the system or once the system is recovered, the trials that must be done. Adam, maybe you can also help with the response.
So I'm just trying to get my head around the question. So in terms of, so once there's been a foreign body found, like the positive signal, how many times should that, essentially the calibration or the PVR be repeated? Is that sort of where the, as I understand it, the question is going?
I think so, Adam. Yeah. So is it a false positive, or you know, what do you need to do to prove one way or the other?
So there isn't, as sort of Mercy said, there isn't necessarily a global standard. It's very much down to the site process. So it's quite regular practice, especially in the food industry, that products, once there's product in the bin, that product at the end of a day, a shift, or a batch could be re-inspected to understand whether it is a false positive or whether it is once again contaminated, and therefore further investigation work needs to take place. That again is quite commonplace in the industry, but it comes down to the site, and also a lot of it comes down to sort of retail codes of practice, what they will and won't accept. So for example, depending on certain retailers, any product that goes inside a bin which could deem to be contaminated then must be destroyed. So in that event, that limits the option for rework. So again, it depends on who you're necessarily supplying, but also what the factory process is in terms of understanding from an investigation point of view, whether it is a false positive, which therefore the metal detector or the X-ray needs updating, or whether it is indeed a contaminated pack, which then needs to go away for further investigation, and obviously the foreign body found.
Makes sense. Thank you, Adam. Christine, why is metal detection not applicable for glass packaging?
Well, it's a good question, and it should be more of a half. So a lot of glass products have metal lids, and obviously that would then disqualify. If we look at sort of a lot of the products on the supermarket shelves for preserves as an example, and even to the point where you have a lot of sauces, generally speaking, they have metallic caps, and obviously it's that metallic cap that would then exclude it from a metal detector. Now, in the event that metallic cap or lid or closure, any one of those three terminologies, is not present, then there would be an argument to say that a metal detector could work. So it depends on where in the process you would necessarily inspect the product.
Thanks. Question from Ramakri, that's all I can see, sorry. Does product composition, e.g. moisture, temperature, salt content, affect detection sensitivity?
On what piece of equipment? Because the answer is different in both. So in answer to the question, it's yes to both, but in different formats. So I'll let Dave go into more detail on the metal detection side, but in specific to an X-ray, salt content definitely has an impact on sensitivity, because actually salt is a good attenuator and absorber of X-ray radiation. And what that means is it can make a product denser because having high levels of salt. So that in itself will impact the potential results. So that answers the X-ray part. From a temperature element, it doesn't necessarily impact the performance, but one of the things we have to be careful of is the X-ray cabinet, which houses the generator and the detector, need to be kept within certain temperature controls to ensure the electronics don't essentially get overheated. So while temperature doesn't impact the performance of the product when it comes to the inspection, it does have an impact as to the overall system itself. So to answer the question from an X-ray, salt definitely impacts performance. Temperature doesn't impact performance of the product, but it impacts the performance of the system. And I'll let Dave go into more detail from a metal detection perspective.
Sure.
Yes, from a metal detection perspective, so all of those will increase the conductive kind of footprint of the product itself. So moisture, increased temperature, and salt content will make the product itself more conductive, which will mean the metal detector has to alter the settings to account for that, which means it will have an effect on the sensitivity of the metal detector by reducing the sensitivity of the metal detector, and the ball size inspection will gradually increase depending on the level of moisture, temperature, and salt. So yes, it does have a negative effect on the sensitivity of the metal detector.
Right, thanks, Dave. Question from Vanessa. Sometimes the rejection is very aggressive for the packaging, damaging it. how does the design of the equipment, how can the design of the equipment avoid this situation? E.g., example, RT food in MAP.
Okay, I mean, it's a really good question. So there are lots of different types of reject device and obviously also reject aperture. So for example, if we take an example of a yogurt tray, you don't necessarily might not want a gravity fall bin where obviously if you drop it from a height, it could explode at the bottom. And that's where we could potentially utilize a reject chute, which would then gradually take the product away from the conveyor into a lockable container. That's one example of a way. In terms of the actual reject device itself, there are pushers, there are air blasts, there are lift flaps, there are drop flaps, there are retract bands. So there are lots of different ways in which we can remove products from obviously the good path that would then go further upstream. And it'd just be a case of evaluating the product itself, the packaging material, what's it at risk from? Is it at risk from a gravity drop and therefore destroying it as an example? And therefore making sure that we have the relevant device that can mean that in the event you need or want to rework a protected inspected product, we have the ability to reject it into an area that doesn't fundamentally destroy it. So there are lots of different options. I can't necessarily say specifically to your application as to what you've got and why it potentially might be destructive, but there are other options that can be considered.
Great, thanks, Adam. Question from Millie. Our product is packed with blue plastic roll, MDPE, but sometimes errors happen in cutting, sealing, and pieces get into the product. We've already made preventive corrective action to the sealing machine, but can X-ray detect this plastic?
Well, the fastest test that you can do is grab a glass of water and drop said material into that and see whether it floats or sinks. If it floats, then there is a very high probability it cannot be detected. If it sinks, then it's definitely worth pursuing in regards to testing before you look to invest. So hopefully that answers your question in terms of finding out whether that particular material can be identified or not.
Is that both with metal detection and X-ray?
Well, metal detector, of course, is primarily metal. So if it's a plastic packaging, a metal detector wouldn't be able to eventually detect it.
Okay. Question from Vanessa. How to check the effective rejection in the pipeline metal detector equipment? How to check?
I'll jump in on this one.
Okay, got it.
Yeah, no problem. Sorry. So one thing that we do when we set up the metal detector itself and design the metal detector, so you've got the metal detector search head element, and then you've got a reject valve usually, and I think that's what we're talking about here. So when we design the equipment, we'll get all the product parameters that we need from a point of view of density of the product, speed of the product, all of those parameters, and position the reject valve accordingly in relation to that. So we know that from our perspective that our calculations on the basis of the information given, that reject valve will be able to react in time, because the metal detector head can react very quickly, and the reject valve is a mechanical item which needs a bit more time. So that's the first thing we do. And also to actually test it and ensure that we can offer a system with dual reject valves, which will enable the testing of the primary reject valve, so you can validate whether the metal detector is working and rejecting that test piece.
Right, great, thanks, Dave. NS Brunei, do we need to send our metal detector test piece for calibration?
So generally, you wouldn't need to do that, but we would just recommend that to potentially replace the test pieces periodically when there's any sort of form of wear or anything like that. So not necessarily send it for calibration, but replace them sort of certainly periodically.
Okay.
And also, it's also worth making sure that when you're buying the test pieces, that you get a certificate as well to obviously guarantee the density values and make sure. So again, from an audit perspective, when you are using those test pieces, you have that certification available to show the auditors.
Okay, thanks. Question from Mohammed. I am facing a problem, which is your X-ray machine is for packed products only. However, I need it to detect bones and cartilages in exposed chicken breasts and thighs without any packaging material.
Okay. Well, there are solutions that can help you with that. So what I would say is, if you do know your Mettler Toledo contact already, please reach out to them and we can go through that in more detail. Obviously, there are things to consider. We have to remove the curtains, so we have to look at different mechanical designs in order to remove that protection element, which obviously is going to interact with what we call a naked product. But there are solutions that are available and we can walk you through and discuss with you on what they might look like. So please reach out to us outside of this forum and we'll make sure we come back to you with how our systems can do so.
Very good. Raj, can colour difference in a product be recognised by an X-ray inspection machine?
So X-ray is all about density. So if a colour difference has no density change, it won't be picked up.
Okay. Question from Lord and Sanchez. What are the most common causes of misdetections in metal detectors and X-ray inspection systems, and how can facilities proactively address these? Also, can you share practical tips on validating and verifying the performance of metal detectors and X-ray systems as part of a food safety management system? So the first part of the question, let's stick with that. What are the most common causes of misdetections in metal detectors and X-ray inspection systems, and how can we address those?
Well, so if I answer both the questions from an X-ray perspective, and then I'll let Dave jump in on the metal detection side. So in terms of common misdetections from an X-ray, it will be whether the foreign material itself is not denser than the product. This has historically always been the challenge. So if we take the example of an agricultural product, so a bag of pasta, which might be say 500 grams or a kilo in a supermarket, one of the common risks is a stone. So a stone is obviously, depending on where it's from, it will vary in density. So one of the previous myths would be necessarily that stone not being dense enough in relationship to that product to be able to stand out and therefore be detected. The good news is there is newer technology now, such as dual energy, that can add value there. But fundamentally, that's always been one of the keys, whether the product has previously not been dense enough. And that, for example, also relates to bones in chicken. It obviously has a significant relationship to plastic due to its low density, rubber seals. So fundamentally, missed detections on an X-ray primarily come down to the foreign body itself not having a significant enough density to trigger versus the product. So that would answer that one with regards to X-ray and mist. So it's all about density. In relationship to the performance verification side, so with X-ray inspection, you have the ability to set up routine PVRs on the machine, which can essentially, whether it be every 2 hours, whether it be every 10,000 products, and you can also set the machine up to have certain fail-safe conditions so that if the PVR is not met, it obviously then goes into a fail-safe. In terms of the practical elements, if you want to remove the requirement of constant destructive testing, there's a discussion around building trainer packs that have similar density values, and obviously you can then insert your test piece to those. In terms of best practice, it is best practice to have the test piece inside the product from a PVR perspective, but of course there are limitations around the product itself, where the X-ray is, and also necessarily whether you always want to do destructive testing. But generally speaking, one of the big differences from a PVR perspective, and there are some considerations, but depending on the height of the product, there isn't as much of a requirement to worry about whether the test piece is at the top, bottom, or middle. But that is good practice if you want to really validate. And that's the difference between validation and just performance testing. Validation, you want to put your test piece in various different pieces to make sure you're always having detection levels. A PVR just might be an agreed on single position within your product as part of that individual routine.
Okay, and thanks, Adam. So from a metal detection point of view, because you covered a lot there in general, but specifically metal detection, yeah, it works on conductivity. So potential causes of misdetections there really relate to not necessarily the density like X-ray, but the conductivity of the material going through it. So one thing that happens with a metal detector, it has orientation effects. So depending on what orientation the metal is going through the metal detector can affect its detectability. And also the different metals have different conductive footprints as well. So with stainless steel being the most difficult to detect, So it could be if stainless steel is going to the middle of the aperture and it's a long, thin contaminant, then that might be something that's difficult to detect for the metal detector. So it's important to understand the orientation effect when we're looking at misdetections. And also it's important to understand how the actual system around the metal detector works and how it's actually handling the rejects, and whether you've got an effective system of that rejected product going into the reject bin or basically not going into the product flow. So are the reject methods, are the reject mechanisms tested as well? Do you have an effective overall system that makes sure that that contaminant that might be detected by the metal detector is rejected and taken away from the production successfully? So that's another side to it as well.
Hopefully that sort of long answer broken down into 2 pieces covers that question.
You're on mute, Simon. Simon, you're on mute.
I'm sorry. Thanks for that, Dave. A question from PK Shikipur. How should we dispose of X-ray tubes end of life?
So it's a really good question in terms of generally they need to be disposed of in a particular way. It depending on the relationship with a supplier that you might have. So for example, we can, within Met Toledo, we can provide a service which will, because for our systems, you don't necessarily just replace the tube, you replace the whole generator because it's a sealed unit. We can take that away and destroy that for you, essentially. So that is a service that we offer. But it's a good question. It's going to depend on each individual country in regards to what their regulations are. So it's generally worth understanding that as a precursor, and then contact your necessary supplier as to whether they then offer a service to do that on your behalf.
Okay, thank you very much, Adam, Dave, and Mirs. Excellent questions, brilliant presentation, lots of great practical guidance and information on the regulations, standards, non-conformities, and actually practical steps of how you can alleviate them and improve your food safety management system. So, and the question and answers, we've run 17 minutes over, but it really adds so much value to the presentation. So thanks for everybody for joining in with that. So yeah, that's it for today. Thank you for attending, everybody. A big thanks to Adam, Green, Mercy, Sanchez, and Dave for sharing their knowledge on contamination detection. I'm sure you've gained lots of valuable insights. They'll be following up with the recording, slides, and the certificate later. And if you do have questions more deeper related to your products and process, I'm sure the guys at Metal Toledo will help you. So yeah, it's all about being proactive and improving. And so let's all stay connected. And thanks. Have a great day, everybody. Appreciate your time.
Thank you very much indeed. Have a great day.
Yeah, thank you.
Cheers. Bye-bye.
Thank you. Bye.